All right. So, um, what we'll do is let's just kind of take a quick peek into last week's material. Let's see, second. And um, it seems like we understood pretty well how to handle these. These are, pretty good activities for us. The whole website here, the link to the Linux Journey website is here. The Ghost Septillion website, the Ghost terminal is probably going to go offline pretty soon just because it's not really being used much. So, but I think I'll put a note to where it will be cut back on um probably like a year from now. But I'm gonna save everything. I'm just gonna just stop the compute engine instance thingy that I have running. The little it's supposed to be in the free tier, but it's not. So, the fees are starting to climb up to like maybe $6 or $7 a month, which isn't still that bad, but I don't know. It's no point for that. It seems like everybody has their own setup, so that's great. Um, but for the last few weeks, tonight and also tomorrow or next week, the assignments will be coming from this particular website. And so the expectation is that basically you would click in here. It talks about processes, which we've done before. Um, Early on, we talked a little bit about processes, at least how to display them and how to kind of modify what's displayed on the terminal. But here we're going to dive a little bit more into the processes and understand their functions and how to kill them off. And then that last quiz question, as I stated, when you get down to the chapter 11 and you go through all of these commands, they're going to ask you a question here. You'll get it right. Snip this out, somehow insert it into a document to upload onto the Canvas, and I'll give you the credit there. Um, it's understood to, complete all of the chapters. It's all just great stuff. It's for our own benefit. And it's all aligned too with the course material. And it's definitely Linux administrative stuff too. So it's pretty good to get into that. And so there were a few others as well. There were like three in total. Oh, click on here. Let's see here. Yeah, so again, processes, devices, and then packages, which I'm sure we know a little bit about all of these, even heading into the formal assignment. All right, and we are now on the verge of week 10, and it is the final week. Week 11 is finals week. So instead of meeting you, the exam will be open. It should be open um, a week from now. And I think I said I would keep it open for 2 days. So it will close Thursday the 13th. Ooh, lucky number 13. Spooky. Uh, well, at least it's not on a Friday. Which it almost could have been if the first was on a Sunday. But okay. Um, Probably would want to tackle it as soon as you can. That way, just everything is done. And it will probably automatically grade it. And, so the instant feedback, we're aiming for about 25 questions, 20 to 25 questions to cover just about anything we spoke about. Not everything, but anything. That was on the table. And yeah, that'll pretty much wrap up our time here. It's been a grind. You guys have been pretty consistent, and it's been good. It's been really good. And the course is developing. There's probably going to be some kinks to modify, and um it's still, we're it yeah, the IT department is always constantly under construction, as you'd imagine. There's a lot of things that can be improved upon, um but yeah, thanks guys for hanging in there and taking this course, and so hopefully you guys get to your next pathway and your next set of courses, and keep the grind alive. You know, it's it's so important to get it everything, all the paperwork, certificates, degrees, and all of that good stuff. Um, and also just the knowledge and understanding the direction that you want to head. Um, so, yeah, some of these are pretty straightforward. Let's take a look at the process utilization, and then we'll talk a little bit about the kernel. I have this activity which I've never done before. I'm going to see if it works on my machine, where I'm going to create like this kernel module and activate it, and we'll just see if it works out. So, but let's take a quick look at the process utilization, which is kind of like a part two of processes. So let's get there real quick and kind of just see what's happening. All right, so we go over how to read and analyze the resource utilization on the system. It also shows some great tools to use when you need to track what a process is doing. All right. We've seen the top command before, it's kind of let me just see, let's make sure that we are, let's see here. It just freeze out on me. All right, so if I type top, T-O-P, right? This is what it gives us, our little spit out of this command. And let's try to make this bigger. It's super hard to see. All right, so, and again, they're saying tracking processes. So I guess the command for that is top, right? Um, and here's what it gives us, which is kind of what they tell us here, but obviously there's only one process happening. Um, so not much really happening, not much CPU or memory being used at this point. It's pretty just flat. Oh, now we're getting okay. It's running now. So we got 6 total, 1 running, 5 sleeping. Interesting. So we do have processes running in the background, and the kernel is responsible for that. And remember, processes are going to keep like the lights on, right? Like if our house is a computer, when you have things connected to outlets, it's there's going to be electricity running through that item. Um, and so the processes kind of remind me of that, like the flow of electricity, and they are making things happen. Um, and the kernel actually has uh, it manages the processes, like the order in which they fire off. I mean, if you think of like computers, this architect is still pretty primitive. I mean, it's still a 20th century thing, and so the same thing with like a cylinder engine. Um, there's a certain process in which the spark plugs ignite, right? And I don't know the actual order. Some of you probably do, but depending on the type of how many cylinders you have, right? Like four, six, or eight. There's a certain configuration in which they fire, which is supposed to give off some type of optimal type of generation so that when the pistons go up and down, which um spins, certain things, it's not gonna like um fumble with each other. They fire off in such a way that it's just some kind of optimal kind of design, right? Um, it's the same thing if you're screwing something in, like you're connecting your motherboard to the, you know, to the studs that it's going to sit on in your box. Usually they say, well, you know, you obviously set it in, line up the holes, but when you actually screw, sometimes they say to screw diagonally, um, and you want to do a little bit at a time for all four, so they get about halfway or even a quarter way through before you begin to start to tighten them. And it's just one of those things that separates the amateurs from the pros, when you're building certain things. And you just learn through experience that if you didn't do it that way, it could potentially be a problem. I mean, it's sensitive material, something could crack, or it may not line up the way it's supposed to anymore. Who knows? Um, so, there is kind of a firing point on how processes are managed. And, if I pulled up the processes in my machine, if I right click on my start menu and go into the task manager, I mean, it's a little overwhelming to see. Um, I mean, this is actually revealing a bit much as well, but oh, the zoom is very high. So processes on the Windows 11 machine, and I haven't even scrolled down. Um, I think there's a point that says running in the background too. Let's see. Okay, no, they didn't say it, but yeah, no, this is just, I mean, just to do what I'm doing. Obviously, there are probably some things that's running that is not being utilized. Um, but it's just everything's just going cuckoo right now. Um, when you look at the performance, well, some of my GPUs are being used. Um, yeah, that's not too bad. I mean, that's obviously this was really good at the time. Now it's probably, you look at it like, this is a 2070. Now I think what's standard, everybody has like the 3000s and above. But it still works for me, so it can still do what I need to do. But yeah, I mean, the processes are responsible for quite a lot of things. My Wi-Fi, Ethernet, even though Ethernet's not being used, it's still active, and memory, whatnot. So pretty interesting stuff. Um, you don't get all that when, in the Linux machine, but hey, I mean, it it's kind of the bare bones, bare minimalist types of uh, presentation. So, so I'll talk a little bit about that, break down what is happening. This is all good stuff. And then you can also specify a process ID if you just want to track the certain processes. So the top command will accept different types of options. Let's look at this. Let me try that list of command. Let's see here. And Joseph, I'm seeing some suggestions on next steps with Linux. Um, what was that? So there was a question in the chat. I think I'd come into it a little late. You said some suggestions on your next steps?
Well, you were talking about, how the class is going to end and how much, we've learned and good. And I just was thinking about where from here.
Yeah, absolutely. I would say, I mean, obviously you see as you take in these different classes like cloud, Linux skills are going to be pretty important. And again, it doesn't matter which cloud, if you name off the top three, Azure, AWS, and Google or GCP, the they all have GCP. I just love so much. I was like one of the first users to use it, and before a lot of things were hidden, it was pretty powerful. But they give you, if you have a Gmail account, you can log into the cloud, and they give you this little terminal which has about 5 gigs of space, and it's a lot. It's some type of flavor of Linux, like it honors Linux commands, and um and almost everything that you do that you can do in the user interface can be done in the command lines. Um, I never really liked the help menu in the Google Cloud. It was just okay. I just felt like it was taking too much of my time, and it was kind of hard to find like the commands that I was really wanting. But I guess if you do put in the time, you kind of eventually get to what you want or figure out if it's even there at all. Um, but nowadays, it's been around so much that whatever you're trying to do, it's probably already been tried. And so there's going to be resources, especially like GitHub. And and nowadays it's everything is just it's all about the chatbots, you know. And ChatGPT to me is still number one in my book. Um, and so I'm starting to use that a lot more than even Google. When I sometimes I think Google can do what chatbot can do, but the chatbot um to me is outperforming Google, and it just saves so much more time. And it's somewhat credible, like the response. I mean, it is what Google would have probably said anyway if I found it eventually. Um, and so it's kind of important, like to be able to find what you're looking for, because then you're able to get a little bit further down the road. So but yeah, but as far as next steps, you definitely want to not only have your own knowledge of Linux, but you want to decide on what certificates you're going to need to take. And since everyone is taking this class, you might as well um, plan on doing some kind of certificate for Linux. Now, which one you decide to do is on you. Um, I've provided some resources in the file section, and you know, hopefully you've been able to tap into some of those resources, because this course was kind of just a warm up and an introduction to Linux systems. So now we have an idea of what the course is all about and what's expected, but you still will have to do some more test preparation. Um, it's not This course isn't at the point to where our final exam is going to be the certification exam, and then therefore you end up getting I could issue the cert, or you take it down to some place and they'll you know no, it's not there yet, but I know there are some classes that they used to do it that way, but the coordination of that, and also I think there's been budget cuts to certain things as well, that is just not readily available anymore. But there is vouchers available. The problem is it's just a lag. It's a huge lag. So by the time you put your name on the list to have um, to get a test voucher so that you can take a certain certification exam, it takes about 6 months or so. I don't even know exactly, but I do know that there's a lag, and the lag is still present. Um, I might have made an announcement about it at one point during our class. So if we ever go into the announcements inside of Canvas, so I don't know if you have notifications on or anything, but there is I did at one point post a voucher information, and I think they said it closes by April 29th. Hmm.
Well, I received a voucher from Ryan. So
Okay.
yes, yeah, you did do it, and I asked for one. I got one. Yes.
Awesome, awesome. Yeah. And I also told them that, originally it listed Linux Essentials. However, you could decide to do any one you want. And I think the
He
Linux,
sent he sent Linux system administrator.
okay. Huh. Yeah, so I that's what what was that? That's what I would focus in on is really just being strategic about your certifications and your next move, like where you want to land.
Right.
Um, because even if you're not using it, it might be handy to go for it. And then it's just a matter of um, passing the exam and then marketing yourself and start applying to different things and whatnot. So there'll be there'll be a lot of good opportunity, I believe. Um, even in this technology day and age. So let's take a peek at one of the other topics real quick is booting the system, and then we'll look at the kernel. And so here you see the BIOS initializing. So and for us again, and most people too, almost everybody nowadays is using Linux, but in a virtual machine setting. And when you first set up your virtual machine, whether you're using Workstation Player or all these virtual box or whatnot, there is still a BIOS. The virtual machine will kind of manage it though, right? We don't really modify it too much because we're kind of it's all virtualization. But um, it's still kind of important to understand the pieces to what goes into it. And because the BIOS, from my understanding, is really the main computer with no operating system on it, right? It is really the core of the computer. But when you load the operating system, then that begins to become the new computer. It like takes over, the uh it supersedes the BIOS, and now the operating system is now functioning as your primary source of the interface, right? So to transition from the BIOS to the actual operating system, there are certain like steps that will need to happen. And again, keep in mind that our our Linux machine is really a full computer. It's just that we just don't have the desktop running per se. But we could get that running if we wanted to. Um, so it's not like it doesn't exist. It's just not being pulled up. Again, it's the minimalist approach. Um, and I think if we were operating with Linux on some sort of desktop, we would be, we all would be extremely comfortable. Um, So I figure we're just gonna stick solely on the command line, because you could pretty much do pretty much everything you want to do on the command line. Obviously, um, if you're the user experience though, if you're like using it, all right, you probably might as well just use a desktop so you could watch the internet or download pictures, modify pictures, and whatnot. As a user, it would make sense to use the desktop. But as an administrator that is responsible for managing the system and the users of the system and carrying out certain tasks, there's no point to use the desktop because we could just use the command line at that point. So it's that kind of thing. Um, and so the boot process has a specific order as well. Um, and so here, this one is really focused on the bootloader will load the kernel into the memory and then starts the kernel with a set of kernel parameters. Now, kernels can be modified and customized a little bit. And again, we're going to try to do this module, a kernel module thingy. And then here, the init process is the first process that gets started. Init starts and stops the essential services process on the system. And so there are three major implementations of init Linux distributions. And so as you continue to click on these, it kind of goes through what you need to know, like the gists of everything here. And it's good to have a nice broad system. Now, I do encourage that um, if you do want to read more on certain concepts, um, I'd recommend certain books that I've already kind of put into our space. And if I'm not mistaken, I think the Root Linux book, which is one of my favorites, probably has some good information as well. Let me take a look real quick. Um, let's see here. Okay, man, that's good. Oh yeah, the IP protocol. Hmm. See if I remember this. Hmm. Yeah. So we do have access to some books that do have some information on the kernel and things like that. And there's other books out there as well. Um, I could even give you guys this one. This was a book I was just kind of reviewing a little bit. And it's pretty big. I mean, it has, let's see, go to the table of content. I mean, it has like 1,000 something pages, right? Um, and it's all about the architect of it. But this is more for the advanced level. It's a good resource. Um, yeah, maybe I could drop this in as well, just so that we all have, just in case for our own understanding and understanding the architect, because um, yeah, they get into it in chapter 2, the process management and scheduling. So the way the processes are scheduling, so the way they fire off, that they wait in line kind of. Now, but if you have multiple cores, then that's a game changer, especially if the operating system is programmed for a system that has multiple cores, because now you're able to fire off processes at the same time, more or less. Um, so yeah, that's a resource. In fact, before I forget, let me, it's professional Linux. Yeah, let's just put that in there now. I'll drop that in and then we will, let's see here. Let's just make sure that that's the right one there for that. I'll put that in ebooks. All right, so that's going to be running. Um, I just got to note that my internet is a little unstable, so bear with me. Oh, let's try one more time. So, and let's take a look at that last one, which talks about the kernel real quick. Um, it would be here. And so, the kernel is considered to be the core of the operating system. Just going to highlight that. Um, the basic level is hardware, the physical layer, and then the next layer is the kernel, which handles the process and memory management, device communication, system calls. It sets up the file system, and the kernel's job is to talk to the hardware to make sure it does what we want our processes to do. Um, and so the machine that I'm running, which I recommend if you're on a Windows 11, is let me try the uname command. Okay, let me do the, let's see here, one second. There. So my setup is WSL2. So if you have the WSL2, this is the newer and improved, faster Linux, and it has a kernel built inside of it. So one could argue that, yes, it is truly its own computer inside of the Windows operating system. Um, there's the other one which has a one WSL1, but you could just simply upgrade it to 2. It's a little tricky. I forget the commands, but it can be done. It should, I mean, especially depending on the type of setup you have. I think you might have to have Pro. I'm not 100% sure. I forget what the requirements are, but it's worth looking into. And this could be potentially pretty handy for you. Okay. Depending on, again, what the setup is for your machine. Um, so here, let's look at some of those chapters real quick. Here, talking about privilege levels. Um, why do we have the layers? What's up with that? In kernel mode, the kernel has complete access to the hardware. It controls everything. Um, pretty interesting stuff. It's kind of job specific though, right? Like not everybody walks around with this kind of knowledge. You kind of have to be kind of into it. Um, kernel installation. So the command will tell you your kernel version. Um, so mine's, which was the version of my kernel is here. Pretty interesting stuff. Where is it located? So what happens when you install a new kernel? The files are going to be added into the boot directory. You'll see multiple different kernel versions inside of here. So if I go to my boot directory, let me just see here. Oh, let me get to my root directory, and let's see, there's boot. So let's do cd into boot. Whoa, nothing. Let's list out all the files in the long format, all the hidden files. Zip. Nothing's in my boot. No. Well, yeah. Well, I mean, it doesn't need to really be booted, right? I mean, it's already a part of the system, so nothing's really going to be in there. So this was a bad example. Yeah. But now if I were to install a new kernel, well, it probably still wouldn't be in boot because I don't even think they'll let you do that. Yeah, I'm not sure. That'll be interesting. Um, here's where they talk about creating kernel modules. So it says, let's say I have a sweet ride. I invest a lot of time and money into it. I had a spoiler, a hitch bike rack, and other things. These components don't actually change the core functionality. Um, the kernel itself is monolithic piece of software. Okay, this is all fair. And then it says kernel modules are pieces of code that could be loaded and unloaded into the kernel on demand. They allow us to extend the functionality of the kernel without actually adding to the core kernel code. So we can also add modules and not have to reboot the system. Um, so if you type ls-mod, this will list the current modules on your kernel. Um, like, let's just go back to here. Let's clear this. So if I do ls-mod, I shouldn't see anything. And I don't. I have no modules. I have no need to add any type of module to this. Haven't had to do that, but it's all about customization, getting comfortable with what you want to do and researching the different types of modules that are common. Um, so here's something here they're saying it's just an example, some random example. Um, the mod probe is how you would load a module. So apparently there's this module called Bluetooth, right? Maybe it could be that you want to have Bluetooth on your machine. And it has, you know, you, it doesn't have it and you need it, then you could add it using the mod probe. You could remove it with the R command there, R option. And now we'll remove the module. Load on boot up. So let's go read this real quick. It says you can also load modules during system boot instead of temporarily loading them with mod probe. So you just modify mod probe. So you go in here, you have a configuration file. This is what it looks like. You would modify that, and then it's done. Pretty interesting stuff. Um, so now I'm going to try my example of um, adding a module to my machine. So I have an example that I used here. It's kind of, let's see. I'll move it over here and just start typing in the commands into my screen. So The first thing we're gonna do, let's see, hold on. So I'm gonna create a simple kernel module file first, and we're gonna call the file hello C. So what I'll do is go to nano hello C. Oh, and let's just make sure I don't already have the file name hello C. If I do, I'm just going to try to remove it. All right. Well, I'll go to nano hello C, and I'm just going to copy and paste. Ah, there we go. Let me just see here real quick. Let's make sure I copied the whole thing. Um, so yeah, it looks pretty good, I guess. The first thing we have are the two. Oh, this is C. All right, one of my favorite languages. I prefer C over C++. I don't know why, but I mean, I'm not a coder. But anyway, first the header will include the initialization. The other one would include certain functions for creating the kernel. Um, let's keep going. It says static int. That's just a function that will be executed when the module is loaded. Print the kernel info, that will just print the message to the kernel log. Return 0 is good. Exit the function. Um, static void exit hello exit void. That's the function that is executed when the module is removed. We're going to print the message to indicate that it was gone, unloaded. And then at the bottom, we just have the module initiation. We execute the two functions, and that should do it. I'm going to try to save this now. Let's see. Control X, and then what? Save to the buffer. Hello.c. All right. Now, oh crap. Well, yeah, so we have to compile the module. I have a command for that. Let's make sure. Hopefully it works. I don't know if it will, but we tested it out. Make this load modules. You name here, build, blah, 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 and the modules. Okay. Oh, crap. Let's just get this going real quick. Uh, all right. All right. So we just did the make. The following packages are automatically installed and no longer required. All right. Then the next step is to insert the module. So I'm going to do the command sudo insmod hello.ko. This is not good. I need to get to. I think I need to just change my directory here. Let me see something. See, it should be. Let me see. Why couldn't it? Let me double check this. Make does see lib modules. All right, let me try this one more time. And I'll just get back to this space. Okay. And install the headers. Make sure this is probably good already too. We need those. Okay. Yeah, that's so wait, where's the I think I have the I think I didn't maybe I didn't compile it first. Let me double check the command for that. 1 second.
So does it matter that you saved it to the buffer and not to the directory?
Um it's still in the directory as well.
Okay,
Um
okay.
so so yeah. Uh let's see here. So if I just hit ls, you'll see hello.c is here. And we even have the hello. Well, we even have the hello there. Let's go to this. Uh, okay, 1 second. Okay. So when I type, okay, so some things just aren't. It's not working. Let me see here. When I do, so the hello.c is fine, but maybe I should do. Make. Let me see here. Hold on. I wonder if I navigated away from that. Yeah, for some reason it's not building it in the right place. So I'm not gonna I'm not gonna take up too much of the time. But basically all that would have ended up happening, and I can kind of show that um it would have created a module that would have given the kernel information when we log on. Um, and so and then we would just remove it. But it was just a way to um, add a certain functionality to to the machine when we begin to use it. And it was just to demonstrate that um, you can add certain things to the kernel module um, just by carrying out certain commands. But my machine is not. Um, I'm not gonna go down the rabbit hole in this. I could probably figure it out, but it might not even be worth it because the whole point on this was to um, create a C file that is basically gonna talk to the kernel and add to the kernel, and then we had to just make that file and add it into a module, and then activate it so that every time we start the program or the kernel's running, it'll display some information that we want. This is kind of just a cool way to kind of customize the machine, but it looks like there are certain dependencies that my machine doesn't have for me to continue with the next few steps. And so I will probably work on that and try to troubleshoot that. Um, but yeah, in the meantime, we'll just um, and there were probably a whole lot of other like I mean I'm sure we could find many other types of activities that can demonstrate use of the kernel or other labs as well. Um, like from even let's see here, if I were to pull up one of the other books that we've used quite a bit, let me see if I can find it. Um, so let me see here. It's let's move over to. Sometimes you have to you have to search for stuff because these books are they're just so much. So um, let me see here. 1 second. So in chapter 12, right? Let me move over. So there's basically a chapter 12, which we didn't do because we just didn't have the time. We skipped over it. But um there's a section in here on managing the kernel modules and other types of hardware. And so they kind of go through some of the commands, some of the useful commands that you could do. So if it's written in C, you have to create that make file and then somehow load it into what you need to load it into. So here, let's just see. So we did talk about this. So it says like in most other operating systems, you can manually list, load, and unload kernels. So to view all the currently loaded modules, you would use the ls mod command, which is kind of like list modules. And we've done that, but our machines don't have any modules, probably by default. Um, then you can get into seeing, so they're going to add a joystick kernel. So let's say someone wants to I don't know, they're building something, some kind of game. And so this is a system's joystick kernel module. So here's an example of what it would look like. The info to load it, you need to first run deb mob. All right. So they're getting into all of this stuff. It's pretty technical stuff, but um, they've already have the program or the code kind of created. So they didn't really have to kind of do the whole make file stuff. Um, but here it says, and we did this, this is where after this command, we kind of got stuck, but it said you use the less or more utility to review the dependency file, and then that you just built in this, in the module kind of kernel version name and that folder. So when I created it though, it didn't, for some reason it didn't go, like there was nothing there. Um, which was I think part of the problem, because it's supposed to be there after I did that one command, some commands back. It was a few commands back. It was like this command. When I did this command, it ran okay, but when I went to it, nothing was there. And so I went into modules, but now it's going to be another folder name. This is the directory. The kernel version is will be the directory, and then another one which is build. And then inside of that, we have all of this. So if I hit enter again, okay, so it said it didn't, let's see, let's not build. No such file or directory. So maybe I would have to create the directory first. So maybe I could do is I'll do, let's just delete this. Let's delete this. Well, yeah, we'll just do make br. Let's see. Hmm. Yeah, for some reason they're just not letting me do it. Okay. Yeah, well, I'll have to review. I'll have to review this command and see what went wrong. Um, Everything seems okay. Let's see if I just do this. Hmm. Oh yeah. Okay. So I have a directory now, and so we could switch over there real quick. Well, let's just nothing's in there. But now though, if I were to, let's see, if I go to make that file, something might happen this time. No. Okay, yeah, I'll probably just stop here. But this isn't that important to what we're up to right now, but um let's just back into our space. So that's pretty much going to wrap up kind of a little demonstration of how to finagle and work around with the kernels. Um, I'll have to, if I can get it running, I'll make a short little video and send it out you can that you can have, or a link to that video. I could somehow do that. But that's gonna do it for now. I will be available. Feel free to reach out throughout the week if anything comes up, or you want to discuss anything, or and whatnot, and I'll be able to kind of help you through anything that you're working on. But for the most part, I think it's going to be pretty smooth sailing. Um, does anybody have any questions?